The BITRSHIFT function within Excel performs a bitwise right shift operation on a number. Now let's take an example. Let's say we have the number 243 and we want to shift this number bitwise with 2. Then we write BITRSHIFT. The first argument is a number that you want to shift, so in this case 243, and want to shift it with 2 bits. So I close the parentheses and press enter, and there we have the result. Now the BITRSHIFT function is equivalent to dividing the number by 2 to the power of the shift. So let's try this. So we take the number and we divide this by 2 to the power of the shift. In this case it was 2, so 2 to the second power, and there we get the result. Now in this case you can see we get back a decimal number, so what then happens is we take an integer of this number, meaning we'll be rounding it down. So I wrap this in an int function. So as you can see, that produces exactly the same result, but it's not 100% clear why that is. So let's take a look at the underlying workings of this BITRSHIFT function. So let's delete these numbers and start from 500. So we will be performing 10 shifts. So starting at 0, then 1, 2, all the way to 10. Now for each of these shift values, we will be performing the BITRSHIFT function on this 500. So I type BITRSHIFT. First argument is the 500, which we will fixate using the F4 shortcut. So we always use this 500 to perform our shifting. And then we take the shift amount on the left-hand side. I press enter and I pull this through. There we have the results. Now, just to prove that this is exactly the same as taking the integer of the number divided by 2 to the power of the shift amount, I will also demonstrate that. So we have 500, and then we take the integer of the number divided by 2 to the power of the shift value. Just like that. I close the parentheses, press enter, and now I make sure to fixate the 500, so we always use that as a reference point, and now I pull this through. As you can see, we get exactly the same result. Now, to better understand what's going on behind the scenes, we should take a look at the binary representation of these numbers. So we can do this using the function DEC, standing for decimal to bin. So decimal to binary, we provide the decimal number, and out comes the binary number. Now, when I pull this through, it might become pretty apparent what's going on. However, to make it a little bit more clear, I will actually define the places argument. So this is the second argument to the DEC to bin formula, where we can say, okay, each binary number needs to consist out of a number of places, in this case 9, and so then it will add preceding zeros if needed. So then it looks like this. Now what you can see is with this BITRSHIFT operation is basically we have shifted the entire binary number 1 to the right and added a preceding 0, as you can see. So each step here we are putting 1 0 in front of the binary number and removing one number from the back. Now why does this represent a division by 2? Well, let's take a look here. Let's take number 12 and convert this into binary. So DEC to bin for 12 is 1100. Now in the decimal number system, how did we end up with the 12? Well, we had a 1 and a 2 as digits. Now the 2 has a value of 1 and the 1 has a value of 10. So we multiply the digits with its weight for both digits and then we add them together. And that's how we get 12 from 12 in a decimal number system. Now how do we get 12 within the binary number system? Well, we have 4 digits, 1 1 0 0. The first digit has a weight of 1, the second digit has a weight of 2, the third digit has a weight of 4, and the fourth digit has a weight of 8. As you can see, each time we've multiplied by 2. Whereas in the decimal number system, each time the weight is multiplied by 10. Now, just like before, we multiply the value with its weight. We do that for every digit, and we add them together. And that's how we end up with 12. Now, when we're performing a right shift on a binary number, what's going on is we're adding a 0 in the front and removing the last number. So if we perform a right shift on 12 in binary, that would be 0 1 1 0. Once again, let me copy these weights over. And now let's perform the multiplication again. So we multiply the digit with its weight and we add the numbers together. As you can see, we get exactly half. So we went from 12 to 6. Now, why is this happening? Well, as you can see, as we go down one level, so from the 4th bit to the 3rd bit, the weight also decreases with 2. So that is the reason why we are actually dividing by 2 when we are performing a bitwise right shift operation on a number.